So, hello and welcome back to my exploit development playlist. In the last video we did the Riot 4 challenge from Emporium, and this time we're doing the next one, which is the 5th challenge, which is the badchars challenge from Emporium. So let's first of all get the binary yet again. So, and let's read the challenge description. Yes, some characters get mangled as they make their way onto the stack, and we need to find a way to deal with that to craft our exploit. Okay, let's see. Let's first of all start it up in GDB and run it. And it already tells us which the bad characters are. So let's keep note of them, probably. Let's maybe start session here in the middle, and this one exploit again, bang again, the usual boilerplate, pause again, so binary again. We don't want to check info. We can context binary again, and we can terminal again, which is Kitty, which is the terminal emulator I'm using. You are using here. Then first of all, let's get our offset again. Then create 100. Yeah, good spell. That would help a lot. And this probably won't work correctly because some input characters get mangled. So let's see if it finds something useful here. Otherwise, yep, exactly. That's what I thought. So in this case, we can use on cyclic, and then -a to specify the alphabet, and we can use just about anything that's not in the badchars here. Let's specify the length of the cycle until it repeats, and then the length of the pattern we want to create, and that should work. Perfect. Then let's copy this, run our binary, paste it in, and then we have to string at RSP. Let's copy these, and then we can use pwntools again to look it up. We need to specify the same alphabet and the same length and the -l to look it up, and we get 40 again. Okay, at this point I should have guessed it. So now for the challenge itself, it's the same as the right as I got it. So let's see. But we can't push the black txt to the stack that easily. So see how it goes. Okay, this is the POMI function. Do we have some kind of useful function or useful gadgets again? Probably. Let's check. Yep, we have both. Useful function, and this is the same as we had last time, so let's note that down. Okay. Then we need to have the same thing again. We need to move it into RDI, so we need to have a pop RDI gadget again. And then we need to have some kind of arbitrary write again. So that's probably in the useful gadgets. Let's see. Yep, we have that here. R12 to R13. So let's write that down. So let's craft our payload. Let's see how it would look like. Of course, we need our padding at the very beginning. write our first return address, and that's just a bunch of A's again. Then some stuff needs to happen, and then we can, at the very end of RDI, then we need to have our string pointer again. That's then in RDI again, and then we can call print file. And for our string pointer, let's see what we have. So data section is again 8 bytes in size, or 16 in size, that's perfect. And then afterwards we also have another section that is also read and writable, so that's also good. Okay, so that's perfect. Okay, that's the wrong address, or it wasn't, it was the right one. Okay, so now I think this is dangerously close to ASCII. Let's see what addresses we need to avoid again. Let's just call badchars. Close out of it again. Okay, see. Can we just do this? Also not possible. Yeah, I'm not good with Python. Just let me do what I want, please. Okay, that doesn't help much. So that's everything I wanted. So we have our bytes to avoid. X, G, A dot. 1 second. What's this? That. So we can also check our addresses if they contain anything. This is very close, but all right. Yeah, this might be a problem if we increase it. So let's think about that. Our string, the flag, is 8 in size. So yes, this will become a problem. Because this will go right into this area here. But yeah, let's see how it goes. Let's worry about that later. First of all, we need to define the string to write, which is again the egg.ext. And of course, we can't have x in here, and we can't have a in here, and we can't have b in here. So let's check. We have some kind of gadgets here. Use gadgets. Yes, we have some. We have either an XOR, an add, or a sub. We can use either of them. And this also already dereferences them and writes to the address that's pointed to in R15. So let's take a look if we can get our addresses again in R14 and R15. So let's note which one should we pick. Let's go with the XOR one. Okay, and we need to do that to decode an all the things that we wrote to the data, I guess. So we first of all need to encode the string. And then we need to define some kind of key. Let's take 24 maybe. I'm really not sure what to pick here, so we end up with good bytes. Let's take maybe something lower. We can adjust this if we don't like it. Okay. Then, of course, we need to have a decoding loop. So we need for our XOR gadget, we first of all need to prepare our arguments again. And that will be the key, XOR key for the second or first, for the second argument. So we need to have it into R14, and then the first one is the address that we want to XOR, so we want to decode. And for this, we need another gadget that loads our needed things or arguments into these two registers. So let's call Rob gadget again. And yes, we need something with pop R14. And again, we have something really helpful here. This is perfect. Like this. We can load our arguments. So let's do that in loop. So this should be added to our reload R14. And then we need to add the first argument or the second argument for the XOR. So R14 gets popped first. So this is the key, and then R15 the address. So let's do that. Like this. Second is the address. So this is the string pointer offset. Okay, good hit, and then of course need increase offset like so. Then we can already decrypt our string. So what is missing is that we store the encrypted string or the encoded string onto our stack. And for that we need to load it somehow into R12 and have our address to the string in R13. See how that goes. We have then R12, R13, R14 and R15, and then a return. Or we have, I guess it's the same one. It's just, okay, a little bit longer than I would like it to be, but nothing to worry about. 12, 13, 14, and 15. And we have this address right here. Then we finally need to have an pop RDI. And we have that right here. Pop RDI. And then we are basically done, right? So let's see what needs to end up where. We need to have the coded string in R12. Then we need to have the address, our string pointer, in R13. And then we have two values that we don't need, that beef and that beef, that we pop off the stack, and then we move this into here, which is our data section. Then we decode our string. Then we load the string address into RDI, and then we can call print file. Looks good to me. So let's see how it goes. already have. Also, we have this lovely carrot again, after which we can send our payload. And then we can go interactive. And let's give it a try and see if we need to debug it or not. Probably this won't work the first time. But yeah, let's give it a shot. Was string pointer. Okay. See? Yeah, this doesn't look right at all. Failed to open file and whatever that is. That does not look good at all. That's just for reference. Let's print out our encoded string. Probably this could be lower. Oh, of course we don't call the XOR here at all. That's an issue. Now this looks much better. And now we get failed to open file flag T. Okay. X is of course character we need to avoid. So for some reason that gets mangled. Let's try to figure out why. Can't have 7, 8. We adjust our XOR key, maybe that helps. Let's get this back up to, let's say, 13. Yeah, this made it worse. Okay, maybe if we try another one, give this one more shot. Of 5. Back. Yeah, it messes up the same character. So this isn't the problem with our key. Seems to be a problem with the address this lies on. And so we need to think any address we put on here plus 1, 2, 3, 4, 5, 6. Any address plus 6 would mess up. And where we increase addresses is here, the string pointer. And this plus 6 is dangerous. So let's just do this real quick. 8, 6. Yep, this lands us right. This lands us right here. So how do we avoid that? We could do plus 7, then we move this flag like, let me get this straight. So we end up with our address here. So this is the address we want to avoid, right? So if we move the entire flag in this direction, so it starts here, then we would avoid that problem. So that would mean we have 6 plus 6 plus 7 plus 8. Yes, okay, that would probably work. Let's do 8 for safety. String pointer is this plus 8. And let's readability encapsulate that in brackets. Give this a shot. And yeah, that worked perfect. Okay, this time we already got through without debugging, but these challenges are getting a little bit difficult. So let's see how the next one goes.